right, let me give you an example. The example will be maybe close to what we did last time, did when we first did substitution, I mean. Let's see. So the integral from 1 to 2, this time I'll put in definite limits, of x squared plus, sorry, maybe I call this x cubed. X cubed plus 2, let's say, I don't know, to the 5th power x squared dx. All right, so this is an example of an integral that we would have tried to handle by substitution before. And the substitution we would have used is u equals x cubed plus 2. And that's exactly what we're going to do here, but we're just going to also take into account the limits. The first step, as in any substitution or change of variables, is this. All right? And so we can fill in the things that we would have done previously, which is that this is the integral, and this is u to the 5th power. And then, because this is 3x squared, we see that this is 3. Sorry, let's write it the other way. 1/3 du is equal to x squared dx. So that's what I'm going to plug in for this factor here. So here's 1/3 du, which replaces that. But now there's the extra feature. The extra feature is the limits. So here, really in disguise, because, and now this is incredibly important, this is one of the reasons why we use this notation dx and du. We want to remind ourselves which variable is involved in the integration. And especially if you're the one naming the variables, you may get mixed up in this respect. So you must know which variable is varying between 1 and 2. And the answer is it's x is the one that's varying between 1 and 2. So in disguise, even though I didn't write it, it was contained in this little symbol here. This reminded us which variable. You'll find this amazingly important when you get to multivariable calculus, when there are many variables floating around. So this is an incredibly important distinction to make. So now over here, we have a limit, but of course, it's supposed to be with respect to u now. So we need to calculate what those corresponding limits are. And indeed, it's just, I plug in here, u1 is going to be equal to what I plug in for x equals 1. That's going to be 1 cubed plus 2, which is 3. And then u2 is 2 cubed plus 2, which is equal to 10. Right? 8 plus 2 is 10. So this is the integral from 3 to 10 of u to the 5th times 1/3 du. And now I can finish the problem. This is 1/18 u to the 6th power from 3 to 10. And this is where the most common mistake occurs in substitutions of this type, which is that if you ignore this and you plug in these 1 and 2 here, you think, oh, I should just be putting it at 1 and 2. But actually, it should be the u value that we're interested in. And the lower limit is u equals 3, and u equals 10 is the upper limit. All right, so those are suppressed here, but those are the ones that we want. And so here we go. It's 1/18 times some ridiculous number, which I won't calculate, 10 to the 6th minus 3 to the 6th.